Welcome to this explainer. Today, we're taking a truly fascinating journey, zooming all the way from massive global forces down to microscopic toxins, just to uncover the hidden threats to our livestock and ultimately our food supply. We're going to be looking specifically at the vulnerabilities in animal feedstuff availability and the pretty startling reality of feed adulteration.
So let's dive right in. It's really easy to look at a piece of chicken or a carton of eggs at the grocery store and just take the whole thing for granted. But what hidden factors actually threaten the very foundation of that global food supply? Because the reality is, the safety, the cost, and the availability of human food are entirely dependent on the safety and availability of animal feed. If that feed supply chain breaks down, or if the feed gets contaminated, it sets off this massive ripple effect that lands right on our dinner plates.
To wrap our heads around this, we'll follow a quick roadmap. We're starting big with global threats to feed, then moving into the storage battleground, zooming in on pests and fungal invasions, uncovering invisible chemical deterioration, and finally exposing intentional feed adulteration.
Okay, Section 1, Global Threats to Feed. Let's start with the massive external pressures that dictate if raw feed materials are even available to begin with.
We can essentially break these macro threats down into two big buckets: climate and economics. On the climate side, hot and dry seasons induce the absolute greatest reduction in biomass yield for pasture grasses. We're seeing elevated temperatures, higher carbon dioxide levels, and even the invasion of exotic species into pasturelands like Prosopis gilliflora, which just completely exacerbates the loss of grazing areas. Then, on the flip side, we have these complex economic pressures fiercely competing for raw materials. The feed industry is deeply affected by the volatility in raw material prices and exchange rates. Plus, you've got the biofuel industry directly competing for some of the exact same crops used for feed. Add in differing global policies on genetically modified organisms, or GMOs, and you have a highly volatile global market deciding exactly where animals will be produced and where feed will be manufactured. All right, Section 2, the storage battleground. Because once those raw materials actually make it past those global pressures, they enter a totally different phase of vulnerability. We're moving from the global scale to the local feed mill, where the storage warehouse is basically an active, continuous battleground. Once it's stored, feed faces a really serious four-pronged threat. Losses occurring in feedstuffs during storage fall under four major categories: weight loss, quality loss, health risks, and economic loss. And what you should really take away from this is that these deteriorative losses are heavily interconnected. They arise from the foraging activities of insects, microorganisms, and animals, as well as improper handling and physical and chemical changes. Now, the crucial point here is how we actually define economic loss in this context. It's the cost incurred in inspection, prevention, and control to maintain quality standards. But this definition highlights a pretty massive global divide. In industrialized nations, this economic loss, spending money to maintain strict aesthetic and safety quality, is the absolute overriding priority. But in many developing countries, where post-harvest handling might be improperly conducted and quality enforcement is a bit weaker, feed mills struggle way more with the sheer gravity of weight loss and severe quality degradation from insects and moisture. Which brings us perfectly to Section 3, pests and fungal invasions. Let's zoom in a little closer on the biological enemies invading our stored feed. Okay, this number is everything in feed storage: 16% moisture content. This is the absolute crucial threshold. Most feed grains naturally sit at about 10 to 12% moisture, but if that level creeps up to 16% or more, the feed grains become soft, and when they get soft, they become incredibly susceptible to devastating insect attacks. Just a few insect species can attack a sound, dry kernel, but at 16%, the floodgates open. It sets off this brilliant but honestly terrifying biological chain reaction. First, insects feed on the grain. As they multiply, their metabolic activities release heat. They are literally generating so much body heat that it causes moisture to condense on the cooler surfaces of the grain. Suddenly, they've engineered their very own hot, wet microclimate. And step 4, that newly created moisture allows damaging mold and fungi to absolutely explode into growth, completely destroying the feed. And all that fungal growth leads directly to this: mycotoxicosis. This is a massive headache, particularly in the poultry industry. There are over 50 fungal species known to produce these toxins, mycotoxins, while they metabolize the nutrients in the feed. The damp conditions from the rainy season or from that insect condensation we just talked about create the perfect environment. And because there's no way to completely eliminate mold once it starts, feed manufacturers have to actively use chemical measures, like propionate and gentian violet, just to try and control these invisible fungal attackers in compound feeds. All right, Section 4, Invisible Chemical Deterioration. Now we're moving past the living pests to look at the invisible chemical changes silently destroying the nutritional value of feedstuffs right inside the silo. Because, get this, insects don't just eat the feed, they add insult to injury by accelerating chemical deterioration. Take lipid oxidation. This is basically fats turning rancid, which creates terrible off flavors. Scavenging insects actually secrete an enzyme called lipase, which actively speeds up this rancidity. Then you have something called the Maillard reaction. If you have feed with milk powder in it, the lactose sugars have a tendency to react with loosely associated milk proteins. This reaction forms compounds called melanoids. The real problem here, these new sugar protein compounds have extremely low digestibility, meaning the animal eats the feed but gets almost no actual protein value out of it. So far, we've looked at nature and chemistry, but what happens when the danger to our feed supply is added on purpose? That brings us to Section 5. Intentional feed adulteration. Adulteration is exactly what it sounds like, the intentional mixture of a pure substance with a cheaper, low-quality substance. And the motivation? It's simple: money. When feed ingredients like oilseed cakes or fish meal become incredibly costly, unscrupulous suppliers might actually spike them to increase volume or artificially raise the protein tests. The audacity of it is pretty wild. I mean, they might add cheap husks, non-edible cakes, or even spray them with chemical urea just to fake a higher protein content. Depending on the crop, there are all sorts of different hidden dangers lurking, some natural, some totally intentional. For instance, cottonseed can hide a toxin called gossypol. Cassava and linseed can contain cyanogenic glycosides. As we just mentioned, urea is intentionally used to adulterate expensive oilseed cakes and fish meal. Maize and groundnut cake are highly susceptible to aflatoxins, which is a type of mycotoxin, and rapeseed can contain glucosinolates. Every single one of these has to be carefully tested for by feed manufacturers to avoid catastrophic injuries to animal health. And it all kind of comes full circle right here. High-value animal byproduct feeds, like fish meal, meat meal, and bone meal, are not just targets for economic adulteration. They have to be constantly checked for pathogenic bacteria like salmonella. And how does salmonella usually get into the feed? Through the exact scavenging insects, like cockroaches, that we talked about earlier in the storage battleground. It is a continuous loop of vulnerability, from the global climate, to the warehouse, to the chemistry, to human greed. Which leaves us with this final thought. We've seen just how fragile this entire system is. A drought on one side of the world, a few degrees of heat in a storage bin, or a supplier trying to cut corners with urea, all compromise the animals that rely on this feed. So, as global pressures continue to rise, we have to ask ourselves, how do we balance the true cost of cheap feed against the safety of our entire food chain? It's a massive question the agricultural industry wrestles with every single day, and one that ultimately lands right on our dinner plates. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll catch you in the next one.